All right, let's talk about one of the biggest headaches in AI development. How do you take a cool but kind of flaky AI prototype and turn it into something you can actually trust in the real world? We're going to dig into an awesome architecture called the judge and the jury and see how building an automated checks is really the only way to go. So let's kick things off with this quote from a developer named Timothy. And man, does this hit home. I can't sit here and manually check every single execution trace. I mean, have you ever felt that? You build this amazing AI agent, but it's just unpredictable. So you're stuck babysitting it, checking every little thing it does by hand. It's not scalable, and it's a massive pain. And this whole situation really boils down to what folks in the industry call the black box problem, right? You can't really see why an AI is giving you a certain answer, and you definitely can't trust it to be consistent. You're basically just throwing inputs at this black box and hoping for the best on the other side. And let's be honest, hope is not a strategy for building solid software. To get really specific, here's what was happening to Timothy. He had an extraction agent that was supposed to pull product details. But, sometimes it would just fail. It would miss something. And that one little failure wasn't contained. It would pass bad or even empty data to the next agent in line, his inventory agent. And what does that agent do? It crashes. This tiny inconsistency kicks off a whole cascade of errors across the entire system. It's a total domino effect. Okay, so this is where a system architect on the team, Margaret, comes in, and she has this amazing insight that completely changes their approach. She introduces the idea of an automated evaluator. The whole concept is to stop hoping for good results and start designing a system that actually guarantees them. And here's the core idea. Instead of having all these agents just talking to each other and trusting everything's fine, you add a brand new piece to the puzzle, an external evaluation loop. You can think of it like a supervisor whose only job is to stand outside the main assembly line and just watch. It's constantly checking the work of the other agents. You're moving from random, manual spot checks to a system of continuous, automated quality control. But that brings up a really good question, one that Timothy immediately had. How in the world do you automate judgment on something that's qualitative? I mean, you can't just write a simple if statement to check if a text summary is good. And this leads us to the absolute heart of this whole design, using an LLM as the judge. The solution is just beautiful. You fight fire with fire. The LLM as a judge pattern basically means you use a more powerful, more sophisticated AI model to check the work of your other, more task-specific agents. You're basically hiring a super smart, incredibly fast, and totally consistent AI to grade the homework of your other AIs. So how does this judge even do its job? It's not just a gut feeling. It uses a very structured rubric to give a clear pass-fail grade or a numerical score. And it's looking for very specific things. First, faithfulness. Is the output actually true to the source document? Second, relevance. Is it even on topic? And maybe most importantly, it's constantly on the lookout for hallucinations. Did the agent just make stuff up? This takes something totally subjective like quality and makes it objective and measurable. Okay, great. So the judge has delivered its verdict. Let's say the agent failed the test. Now what? Does it just ping a developer and add to their pile of alerts? Nope. Not in this system. This brings us to the next absolutely brilliant part of this architecture, the self-correction loop. And this is key. The feedback from the judge isn't just some note in a log file, it's an actionable command. The evaluator actually sends a correction prompt right back to the original agent. It basically says, hey, you failed, and here's exactly why. Now do it again, but this time pay attention to this specific thing. The loop is officially closed. The system can now fix itself. And what you get is this incredible self-correcting system. It's a workflow where mistakes are caught and fixed on the fly, automatically, often before human even realizes anything went wrong. The system literally learns to heal itself in real time. For building AI you can depend on, this is a total game changer. But wait, there is one more crucial piece to this puzzle, a potential flaw in the whole plan. If we have one AI judging another AI, how do we know the judge is even right? I mean, who judges the judge? This leads us to our final and maybe most important concept, establishing ground truth. This question from Timothy is exactly what every sharp engineer should be asking. It's that classic problem, right? Who watches the watcher? You can't just have an infinite chain of AI judges. At some point, you need an anchor, a source of absolute undeniable truth for the whole system. And that anchor is what we call ground truth. What it is a meticulously curated set of data. People call it a golden data set, full of perfect inputs and their corresponding human-verified perfect outputs. This data set becomes the law of the land for your system. It's the ultimate benchmark that everything, including the judge itself, gets measured against. So how does this work in practice? Well, anytime you want to change something, maybe tweak a prompt or try a new model, you run your entire system against this golden data set. The result is a single number, a system grade. Now let's say your score drops after you make a change. Boom, you've just introduced what's called a regression. You know immediately that your improvement actually made the whole system worse. This is how you stop your AI from silently getting dumber over time. So let's just pull all of this together and look at the huge transformation that's happened here. We've literally gone from a system that was built on guesswork and hope to one that's built on measurement and actual guarantees. And this comparison really says it all. Before, we had a black box. The quality was all over the place, we had to do manual spot checks, and we were always one mistake away from a chain reaction of errors. It was truly a hope-based architecture. But after putting in the judge and jury, we have a self-correcting system. Now we've got automated quality control, continuous verification, a self-healing workflow, and a system that is finally, genuinely production-ready. I think Margaret's parting words to Timothy just sum it up perfectly. When you stop guessing and start measuring, the architecture finally becomes production-ready. This is the whole thing right here. Reliability in AI isn't some happy accident. It's a feature. It's something you have to intentionally design and build right into the core of your system. So, as we wrap this up, I want to leave you with a question to think about for your own projects. What part of your system is still a black box? Where are you just guessing and hoping for the best? What part of your work needs a judge and a jury to make it something you can truly count on?